Okay, so today we do scatter plots and regression equations. What you might have known, like in Algebra 1 you did this, is called best fit lines. That's it, okay? It just that in Algebra 1 you could do a best fit line or you could do a best fit parabola. There was a little bit of that. But now we can actually go further because we know what the shapes of more functions are. We know cubics, we know quartics a little, we know exponentials, we know logarithms. So we're not just confined to linear or linear and quadratic. So a scatter plot is when you graph a bunch of plots, or a bunch of points. And specifically, we're really kind of thinking of real world kind of data, okay? So if we were to go out in Tabb, for all the ninth graders that are here, and take a record of their height and their weight, and then we plotted them, then what kind of a relationship do you think we'd find? What happens to your height, your weight, when your height goes up? Generally. Yeah, generally it increases, right? If you have a low height, you probably have a low weight. If you have a high height, you have a high weight. Now, I could like draw it like this and kind of show it. But the truth is some people aren't going to fall right on the line, right? Some people are going to be here, some people are going to be here, but mostly it's packed around a line here. That's what we mean by a scatter plot. Now, when you look at the scatter plot, there may be, if you can see that it looks like it's got a linear relationship to it, that's what you call correlation. I think I got another slide on this. Right, that's called a correlation. Right. Right. So if you if your points look like they're kind of around a straight a line, and that line would have had a positive slope, that's called a positive correlation. If it looks like they all form a line, or they conform closely to a line, and it has a negative slope, that's called a negative correlation, right? And if it's just like a random field, that would be no correlation. What was I going to say? Something now in statistics world, right? Something like this, if you had data that looked like that, that would be a very strong correlation. It'd be close to 1. The maximum you can get is a 1. A 1 is like if you know the height, you absolutely know the weight. It's like there's no way that that's wrong. This is probably something like 0.9 or 0.9. The truth is, in the real world, when you're just collecting data, sometimes correlation, something like this, you say clearly there's no correlation there. But with the methods we are going to use today, you could come up with a correlation between those two. It would probably be weak. It might be 0.2 or 0.3. But there are, especially in like the social sciences, a lot of the correlations that they come up with are fairly weak. They are like 0.25, 0.3. On a scale of 0 to 1, that's pretty weak. But they're trying to come up with some predictive value out of it. Now, saying it's predictive does not mean, this is like the number one fallacy that people make when they're using statistics is correlations do not mean cause and effect. You can never take that step. Just because you correlated two things, you can't say, oh, therefore this causes this. Right? If you want to show that, you would have to, design an experiment that's very closely controlled, so there's no other factors involved. Run these tests, collect a lot of data, do statistical comparisons, and then maybe you could come up and say that there's a cause and effect there. But just because two things are correlated does not mean that one causes the other. You can come up with some ridiculous things like, I can't even remember because I've read so many of them before, but they just sound, there's two things that, yeah, definitely this one's high when that one's high, but they have nothing to do with each other, right? So just because somebody can say they're correlated does not mean one causes the other. Now, if you have 2 points, if you only have 2 points, then there's only one line that goes through those 2 points, right? That's Euclid. But when you got more than 2 points, if you want to draw a line that approximates these data points, then, I might put my straight edge and draw it in one position, right? And Garrison might do it just a little bit different. Michael might do it a little bit different. We could all make it a little bit different. But you've done this already, what the calculator should have, is you can use the calculator to actually find the best fit line. And the best fit line, measures the error between your line and the data, and it minimizes that. So it's going to find that line which is exactly in that spot, which minimizes the error between the line and the data. It's also called a regression line. Best fit is a regression line. In the calculator, they use, when you see REG, that's regression. Regression line has to do with what you call regression to the mean. That's when they first started using that term, regressing to the mean. Regressing to the mean is like, if you have extreme values of something, you do a measurement, you get an extreme value, and you had to make a bet like, will the next one be extreme or will it be more normal? It should be more normal. I mean, things don't always, end up on the extremes. And that somebody called that's called regressing to the mean. I mean, I heard, so my wife is actually in charge of a sales team, but she's not the subject of this thing. But it's like, imagine that you're like in charge of a sales team, right? And the sales team does horrible. You have the worst week ever, right? And so as the manager, you're going to go in there, one kind of manager is going to go in there and just treat them, oh my gosh, you guys are terrible, and tear them up for doing that. And then the other guy could go in there and be nice about it, oh, don't worry, we'll do better next week. But in both cases, the fact is, if they had one extreme week this week, more than likely it's going to be a better week. They're both people then are going to feel, both managers, both are going to feel like their method worked. But the truth is, after a really extreme, event, you're probably going to have a more normal event next. That's regressing to the mean. So we're going to have to learn how to do these kinds of things. First, we have to know, how do you enter data in the calculator? How do you look at the data? Number one, sometimes just to see, does it look correlated? Does it look like there's a shape there? But also, especially now, what shape? Before you can choose what kind of function to use to model this, you need to know what kind of shape that it has. And then we can, once we get our equation, we can make predictions. So these are all the steps that we're going to be using. So the first thing that I said was, we need to be able to enter data in the calculator. Let me get this set up here. So to enter data in the calculator, you go to Stat, right? You hit this button here, it's called Stat. What do you think that stands for? Statistics, probably, right? Okay, before we go any further, if your calculator's been used for things and you just want to get a fresh start, how do you clear the memory? Yeah, second plus 712. I mean, you're not going to have this data that we're doing, but I mean, let's just say, I'm going to just to show this. So it says, in order to enter the data in the calculator, you go Stat, and you can notice when you hit Stat, on the top of the screen, it's already highlighted on Edit. So you hit Stat Edit or Stat Enter, either one, and you should see columns. L1 for list 1, L2 for list 2, etc. It goes to the right many more columns if you wanted to use them. Okay, and you're going to put the X values under L1 and the Y values under L2. So let's just say that I want to do this, right? X and Y. 1, 2, 3, 4, 5, 6. just to show. I think that'll work. So enter them in. 1, enter. 2, enter. 3, enter. 4, oops, sorry, that was wrong. Delete. Right arrow. Okay, 4, enter. 5, enter. 6. Okay, now if you want to look at the scatter plot, you have to have the plotting of points turned on. And the way you do that is you go second, y equals. If you look at above y equals in blue, it says stat plot. So you go second, y equals. And if you look across from number 1, like mine right now, it says off. That means it's not plotting points. So I need to hit 1 so that I can turn on the plotting of points. Right, so it's blinking on the on, but it's actually highlighted on the off. So I'm going to hit enter so that it stays blinking on. Okay, so now it's plotting of points is turned on. Now, if you just hit graph, it'll show you the same graph background we always look at. But at this point, you want it to zoom to the data. So you go zoom 9, right? Zoom 9. And I only put in 3 points. There they are. You know, it's going to make them fill up the screen. 1, 2, 3 points. So that is how you look at the data. Now, at this point, you would say, does it look linear? And for those 3, obviously it looks linear. So that means I'm going to go to the menu where I get to choose the kind of function that I'm going to model this with. And I do that by going stat, and then you arrow over to the calc, which is on the top of the screen. And there you start to see the functions that you can use to model with, right? 4 is linear regression, right? 5, quadratic. 6, cubic. Quartic, and there's more if you scroll down. But we want a straight line, so we're going to pick 4. Right, and when you do that, you see this screen here, and it says it's taking the x values from list 1, taking the y values from list 2, and then these things we never mess with. Okay, so don't mess with those. Just hit enter 5 times. Right, and since we picked linear, it's giving us the standard equation for linear, ax plus b. You could say mx plus b, but they're always going to start with an a. And then they've given you the values for the constants. So in this case, this is y equals 1x plus 3. Okay, that was step 3. Okay, now, sometimes that's the whole question. Like, you know, what is the regression equation? What is the best fit line? Done. Sometimes they want you to make a prediction using that equation. So like I had y values for x equals 1, 2, and 3. What if I wanted to find the y value for x equals 10? How would I find that? You just plug in 10 right there, right? You just plug it in. Now, x plus 3 is kind of like a very simple, just to show kind of thing. As it gets more complicated, I mean, you could like go to your you know, what if I said, what is going to be the x value for, let me take that back. There will be times when you want to actually do a calculation with this, and it actually serves our purpose to go to y equals and put it there, x plus 3. And now I can go to the table of values, and I can find the y values for any x value. I just scroll down, you know, just keep scrolling down the list until I find what I want. Now, what if I wanted to find the y value for x equals 1,000? Well, do you want to scroll down to 1,000? Probably not, right? So here's a couple things that you could do. Number one, you could look where it says window, right? And above it says table set. And you could always go like this. And like if I wanted to know for 1,000, I could just like, let me just set that to start at 1,000. Then when I go to the table of values, it's already there. It's already there. Okay. Or another thing you could do, which is actually what I prefer to do, is like this. Go to the second table set, and then on the third line down where it says independent, set it to ask. Okay. And then when you go to the table of values, it's blank. So if you want to find the y value for any particular x value, just enter the x value, 1,000, and it's done, 1,003. It'll just spit out whatever. Now, you know, the table, you can set the table to do, like we don't have to have 1, 2, 3, 4. You could set it to 0.5, 1, 1.5, 2. But if you're going to do like odd input values, it's helpful to do it this way because now you can put in whatever you want. You could put in, you know, 1.2, 5.1, anything, and then it'll spit out the correct y value. Okay, now for x plus 3, obviously, that's a pretty easy equation to deal with. But this step right here, right, number 4, is actually something you should learn how to do. Especially, you'll see this as we go on today. This is how you can actually have the calculator put whatever regression equation that you just developed into y equals. So first you go to y equals, and then you go, you see the vars key right there? We used that last block when we were doing what? Vars, y vars, when we were going like the opposite of y1 and to y2. Okay, well now we're going to go vars 5 for statistics, which makes sense because that's what we're doing, right? 5. And then we're going to arrow over twice to get to that EQ for equation. And 1, that you could see what right there it says 1 reg EQ. That's because we just made that regression equation and that's where it was put. So when I hit 1, it puts the equation that I just came up with on y1. Okay, now even better, hit graph and see what you see. And you'll see there's the 3 points and there's our regression equation going right through the 3 points. So you know you got it right when you see that. Okay, so now let's do some more interesting things than 1, 2, 3, 4, 5, 6. Okay, so this table shows the number in Y in thousands of alternative fuel vehicles in use in the U.S. X years after 1997. Make a best fit or regression line. Use the equation to predict the number of alternative fueled vehicles in 2010. So again, how do I enter the data in the calculator? Stat, edit, okay? So if you want to clear the data, which is in your list already, you go up into the top margin and you hit clear, enter, and it'll clear them all out easily. So go into the top margin, clear, enter. Okay, now we're going to enter the X values 0 through 7. So 0, 1, 2, 3, 4, 5, 6, 7. Okay, 280, 295, 322, 395, 425, 471, 511, 548. Make sure you got the same number of values in each list. You'll get an error if you don't. Okay, so now one thing you might want to do is if you put an equation on y equals there, you might want to get rid of that equation so that's blank. And then you don't have to go second y equals 1 to turn on the plotting of points if you already turned on the plotting of points. You just do zoom 9. So we all should have exactly the same graph at that point. Does your graph look like that? Does anybody need help entering data? Okay, it looks pretty good. Does that look like a linear shape? Pretty close. You know, it's got a little bump in there, but it's not too bad. So if you're okay with that being the shape of the graph, and it said make a best fit line, then what are the steps? Stat, calc, 4, and then hit enter 5 times. Okay. So here's our best fit line. Y equals 40.9x plus 262.8. Now notice again, if I just go back to the normal zoom 6, see what you see, zoom 6. You know, it takes you right back to the center of the screen, and you see absolutely nothing, right? Because the Y values are all between 280 and 548. They're way off the screen. That's why you do the zoom 9. The zoom 9 will make sure your data is in the middle of the screen. Zoom 9. Okay, so we made our regression equation. You know, now we need to make a prediction. Use the equation to predict the number of alternative fuel vehicles in 2010. Okay, well, let's see. X years after 1997. So this 0 year is 1997. So 2010 would be what value of X? If 1997 is 0, 2010 is? $13. 2010 minus 1997, right? So X equals 13. So again, you can plug that in right there. You could just do the calculation by hand. If you don't want to do as many calculator steps, you just plug it in, calculate away. Or I can go to Y equals, and I can go vars 5 for stats, EQ 1. Now, when you do that, notice that that doesn't look anything like the line I thought I was going to get, but that's just because it's showing all those decimal places. You know, if you want to be sure that that's right, look at the graph again. See if the line goes pretty much through those points, and it looks like it does. So now I feel good about making a prediction. I think I've already set my table to ask. So I'm just going to go to second graph for the table, and I'll put in 13, and it looks like 794.1. Say, you don't have to do that with the calculator. You could just like write it down and then plug it in and that. Everybody doing okay with calculator steps? Not too hard? Okay. Right, let's try this one. This table shows the U.S. daily oil production, Y, in thousands of barrels, X years after 1994. Let me move this. I don't like that. Okay, make a regression equation to predict production in 2009. I think that's enough. So I'm going to clear my equation from Y1 because I'm going to need that, and then go to Stat, Edit. So we need this time we need 0 to 8. Again, how do we clear the list all at one time? Yeah, clear, enter. And then for the X values, actually I need all those first 7, and then I need one more, 8. Okay, then an arrow over 6660. 1, 2, 3, 0, 6560, 6470, 6450, 25, 6250, 580. Keep doing that. Delete, delete, delete. 625, 580. Okay, zoom 9. So everybody should have the same scatter plot. Does it look good? Now, they didn't really say which kind of function to use here. I think we're going to end up using a line, but does that look like a straight line? Not really. I mean, I could see it having like a few turns in it right there, which might make it like a cubic. I mean, if it's going to start up here and then end down here, then it's got to have an odd degree, right? And so with all those turns in it, it's probably got to be a fifth degree, it's a quintic, which we can't even do in our calculator. So let's just use a straight line. Let's come up with the best straight line that goes through all this one. Stat, calc, 4, 1, 2, 3, 4, 5. It looks like it is y equals. Come on, don't do this to me now. Okay, I'm not going to be able to write there. I can't write it because my pen stopped working. But okay, now I'm going to go to the y equals, and I'm going to go vars 5 EQ 1 for the regression equation. I'm going to hit the graph to see that it goes through those points, and it does pretty well. Right? And so in 2009, what is going to be the value of x? Now, if x is the number of years since 1994, this thing usually gets going then in 2009 it would be 15, right? X is 15. So I would have to go to my second graph for the table, clear, and now I'm going to put in 15. 4,754.1. Okay. Now, let me write this down. Stat, calc, 4. Wish this thing would write. So if you want to find, like in 2009, you plugged in x equals 15. But here's the other thing that you might want to be able to do. How would I be able to tell exactly what would be the x value to the nearest tenth or something like that when the y values equal some number? Not plug in for x and calculate the y, but find the x value that leads to a particular y. So let's say, looking at these numbers here, we know that somewhere in between 4 and 5, this thing crosses 6,000. So how could we use the calculator to tell us what's the x value for y equals 6,000? See if this thing's picked up again. New. That really, yeah. Okay, so here's what you do. If you already did the y-vars thing, and you got an equation on y1, then go to line 2 and put in 6,000. Right? And then hit graph. And what you're going to notice is another line. Okay? So exactly at what point will the production be 6,000? The intersection point. This is the solution to the system. Right? We just turn this into a system. And we want to know where that point is, then how did we use the calculator to find an intersection point? Second, trace, 5, enter, enter, enter. Oh, you know what? That's crazy. My pen had gotten onto white, so it wasn't that I wasn't writing, I was in. Okay, so second, trace, 5. Enter, enter, enter. So, and it's going to jump to that intersection point. It looks like it's 5.4. Okay. So, when you go to the Stat Calc menu, right, Stat Calc, there's a whole bunch of options. If you scroll down, you know, you get quartic, linear. That's another linear. It just switches the order of the x term and the constant term. Then you get ln. What kind of a function is ln? It's a logarithm, natural logarithm, right? Then you get exponential. You get a power, and that's some kind of a logarithm. You get a logistics. Sine, that's the trigonometric function. Manual fit, I've never used that before. Then you're back to, so anyway, we need to be able to understand, like, quadratic, when you see the shape of the data is like that, then maybe you want to use quadratic. If you see that it has like a couple turns in it, okay, well that might be a cubic. Remember, quartic might have 3 turns in it. That's the highest degree polynomial that you can do in the calculator. Remember, exponential could be exponential growth or exponential decay. And a logarithm kind of looks like that. So, I mean, it's kind of a big part of this class is to just have more functions that you're familiar with their shape so that if you needed to, you could model with them. I mean, there's always a few questions on the SOL, which is like, here's a shape, what's the function? And you've got to pick between the different functions. Okay. So let's try this one. And this one, we don't have to make a prediction. We just have to make the regression equation. There we go. I got to get used to that. Okay, so calculator, stat, calc, or stat edit. I'm going to clear my menu, clear, clear, 20 to 70, 20, 30, 40, 50, 60, 70. Right arrow, 372, 462, 509, 501, 437, and 323. Okay, look at the data. Zoom 9. Okay, now what's that line there? It means I still have something on y equals. I need to get rid of those. Clear and clear. Now I go back to the graph. So everybody should have the same shape of graph. Has everybody got it? What shape is it? It looks like a quadratic, right? Because its shape is a parabola. So we're going to have to say quadratic. So when we go to the menu, we're going to go Stat, Calc, and quadratic is number 5. 1, 2, 3, 4, 5. Okay, now because it's a quadratic, we've got ax squared plus bx plus c, and they give us those 3 values. So let me write this down. Y equals negative 0.26 x squared plus 22.6 x plus 23.0. And just for fun, just because I can, I'm going to go to y equals vars 5 eq 1, and then look at the graph. Isn't that nice? Looks like the St. Louis Arch. Do you have a question?
When I hit graph, the dots don't come up on my
Because you have the plotting of points is turned off. Okay. Is anybody getting errors? Do you get any like dimension problems? Sometimes if you get like an error and it says something like a dimension problem, then what you want to look at is you probably don't have any data in the calculator, but you have the plotting of points turned on, and that'll give you an error every time. So turn off the plotting of points or put some data in, right? One of those two. Okay, let's see what the next one is. Okay, let's do this one. The table shows the typical speed of a space shuttle X seconds after launch. Find the polynomial model for the data, and then use the model to predict the time when the shuttle's speed reaches 4,400 feet per second. Okay, so first I'm going to go to y equals, get rid of my equation, then stat, edit. Looks like we're going 10 to 80. Let me go up there. Clear, enter. Clear, enter. 10, 20, 30, 40, 50, 60, 70, 80, 2.4. That didn't work. Zoom. All right. Everybody should be getting a graph that looks like that, a scatter plot. Does it look linear? Well, you know what? It's not that far off of linear, but let's treat it like it's actually doing this kind of a thing. In which case it's a cubic, right? So let's say that's cubic and use a cubic model. Which option is that going to be in the menu? Well, look, stat calc. Which one is it? Yeah, we're going to say that that is cubic. So we're going to go stat calc 6. And of course, the standard equation is going to be ax to the third plus bx squared plus cx plus d. And now we've got to fill in values for a, b, c, and d. And every one of them is a decimal that's like going off of the screen. Now, in this case, they're not actually asking us for the equation. They want us to make a prediction or actually do more like what I told you before. So we don't really need to write the whole thing down. That would be our equation right there. They want to know at what time, meaning what is the x value when the y value is 4,400 feet per second. So how do I find the x value for a particular y value? Right, yeah. Right, so first you got to go to the y equals and put this equation, right? So go to y1 and do the vars thing. So vars 5 EQ 1. And just because I like to watch this, I'm gonna make sure my graph is going through the points. Looks pretty good. Okay, now I'm going to go back to y equals, and on the second line, I'm going to put 4,400. And then I'm going to hit graph. And do you see the 4,400? And why is that? Yeah, I mean, our y values went from 202 to 2,200. That's like what that scale is right now. So it's actually just off of our graph. How do I make it so I can see it? Zoom out, right? Zoom 3, enter. Okay. So now you can see that good cubic shape to it. And you can see the y equals 4,400. So now we want to find the intersection point, and the x value is going to be our answer to the question. So again, how do I do that? Second, trace 5, enter, enter, enter. So it looks like 106.1 seconds. After launch, and I guess that's when the booster rockets detach. And we calculated it. Okay, I think I got one more. Okay, let's try this one. You are storing leftover chili in a freezer. The table shows the chili's temperature, Y, after X minutes in the freezer. Make the appropriate regression equation. So first I'm going to go to y equals and get rid of those equations. Then I go stat, edit, 0 to 60. Clear those. Okay, zoom 9. And then we got to decide what kind of shape does that look like. I mean, in the context of the problem, right, we know that it's the temperature of a piece of food that's been put into a freezer, right? And so what's happening to the temperature as time goes on? It's going down. I mean, is there any chance it's coming back up again? So probably a quadratic is not the right thing, because the quadratic would have that kind of a shape. Instead, it's just going to get closer and closer and closer. You know, honestly, because it's a freezer, if it's in there long enough, it's going to be the same temperature as the freezer. But it's still, this is probably more similar to like an exponential shape, right? It's getting closer and closer and closer to some asymptote that's down there, which is probably the temperature of the freezer. So let's use exponential to model that one. Which option is that in the calculator? That's 0, right? So we're going to say that looks like it's exponential. And we're going to go stat, calc, 0 for exponential, and we go enter, 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 enter. So y equals a times b to the x. Y equals 98.2 times 0.9, I'm going to call it 0.97 to the x. That's the regression equation. And just because I want to see this, I'm going to go vars 5 EQ 1 graph. Now, it doesn't hit every point exactly, but it's a best fit line. It looks pretty good. Okay. They didn't actually ask us to make any predictions here, so the answer was this. So what time is it? I mean, there's only 4 questions to do from the book with the calculator. So you should try to get them. I'm going to also give you a worksheet on permutations, combinations to take home.